considering the fact that your problems can be understood and explained by a person, someone who belongs to your age group. I requested to Mr. Amogh to give his valuable time and talk to you all. I am really thankful to Amogh Johri that even though he has a very busy schedule today, he accepted my request. Amogh Johri, a fifth-year student of IIMTech course of IIIT-Bangalore, has continuously maintained his position in Institute's merit list and Dean's merit list of his institution. He is recipient of 3 international internships, namely GSOC, MITACS, and DAAD, and he has completed work for 8 international papers. Some has already published, and some are in the process. So, without going further or without taking too much time, I just now invite Amogh to talk to you all regarding how to prepare for paper presentation seminar, and also discuss regarding the journey of his journey as an undergraduate student, undergraduate research.
Everyone, thanks for joining. Before I start again, in case anyone has any questions, anyone has any doubts, or you want to speak something, any comments, just feel free to unmute yourself and speak, or you can put it in the chat. Also, that if you're not comfortable with the way I'm going with my speed or whatever, if you want to say something, if you want me to switch to Hindi or something, just feel free to do that as well. Okay, having gotten that out of the way, let's talk about research paper presentation. Okay, so before beginning with the tips and how you go about presenting, let's talk about why are we presenting and why is it important? Is it just like a fun weekend activity that we're just having, or is it something that actually holds some sort of value? So, thing is now a research paper presentation might seem very superficial because like the research paper is already written. Someone has already done all the hard work. They've been probably working for 6, 7, 8 months, whatever. They've written the research paper, reviewers have checked it, blah, blah, blah. All of that stuff has happened and now it's published. So it's someone else's paper. So what are you actually getting out of presenting it? But the thing is, research paper presentation is it's actually a very effective way to understand how good a student or how good anyone can actually understand, or how diligently they are willing to understand someone's research. Now, when you're say working in a field for 6, 8 months, a lot of things become gradually, they just become very clear and very like if you work in a field for 8 months or something, a lot of things will just automatically naturally start coming to you. A lot of questions and a lot of answers will just naturally occur to you. Now, that won't happen when you're presenting. When you're presenting as an outsider, when you begin reading a paper and then you go for presentation, you actually have to be a lot more diligent, a lot more thorough with your reading and understanding in order to deliver a good presentation. Because here you have 2 steps. One is that you need to understand it. And second is that you need to understand it in a manner that you can actually make others understand it in a half an hour span. So it is actually so important that if you look at, so right now it's my 5th year of graduate studies, so I'll be applying for my PhD soon. And if you look at all the PhD applications from most of the top universities, you take MIT, Harvard, Stanford, UBC, all of these have so there are certain rounds that a candidate has to qualify in order to make it to PhD. And there is a certain round of 1.5 hours, which is all about paper presentation. So they'll actually be giving you a paper. If you qualify all the previous rounds, they'll actually give you a paper and they'll ask you to thoroughly prepare it over a month and then come there and present it and discuss about it. So it is that important. They actually value it. They actually value it there. A good presentation can actually, like, that is the kind of value that it holds. Now, coming on to how you can give a good presentation and how it is different from saying presenting a project or something else. So before starting on how you can give a good presentation, let's talk about how you begin reading the paper in the first place, and especially reading the paper in a manner that you can go ahead and present it. So I'll just share my screen if I'm allowed. Yep, I am. Um, Also, one of the places that I'm working with currently right now, so It's actually in a psychology lab where I'm going to pursue my PhD, hopefully. So my professor, so this is actually a study, that my professor did about 10 years ago. And that study basically showed that if a seminar or a lecture is prepared in a very formal manner, then the students who are the participants who are actually listening to the lecture, they don't gain so much out of it because they're receiving the information in a very systematic manner. And on the other hand, if it's not that systematic, if the participants continuously need to think, need to make sort of put in the effort in order to understand the seminar, then they actually end up getting more out of it. So following that, my seminar is going to be all over the place because I have not prepared well. So, but yeah, in my defense, I'm gonna say that I'm doing it, for you guys. Okay, so again, very immodestly, I am picking up a paper of my own. So this is a paper that I worked on last year. It's a pretty short paper. So I just want to go about how, how do you go? You don't have to do anything with the exact paper. It's just about how do you go section by section, trying to understand it and trying to understand it in a manner that you can actually present it. So the first section is the abstract, right? So the thing is, so in a lot of papers, a lot of people might say the abstract is like just a formality, just a brief synopsis of the paper, and which it actually is. But when you're going to present a paper, I would say abstract is one of the most important sections that you can come across. The reason for that is, so a paper has a lot of things, and basic reason, there are a lot of reasons for that. One is that if it does not have a lot of things, sometimes it does not get published, right? Sometimes reviewers will just say that your contributions are good but they're not enough. So a paper can have like 5, 10 different things in there, and if you just focus on those different things, it'll become very hard to make head and tail of everything. Sometimes it just does not add up. But still, every paper follows one, say, there is this one main storyline and then other stuff which sort of branches off it. This main storyline that the paper is going to follow is going to be there in your abstract. An abstract is, in most cases, going to be a very, very brief description of your problem statement, what the problem is, why the problem, why does the problem exist, why is it important to solve the problem, and fourth thing is how are the authors in this paper proposing to solve the problem. Now these things are very important when you're going for the presentation, because if you look at it, this is all that you need to convince your audience of. You need to tell them, you need to convince them of what the problem is and why is it important, right? You need to tell them that, suppose that if this paper, the paper that you're presenting, if it did not exist at all, what difference it would have made and what difference has it made by being there. So the first thing for that is you need to pick on what exactly the problem is, and that is going to be there in your abstract. Everywhere else, they are going to diverse, or they're just going to digress a bit from the topic. Every now and then they're going to pull in different sort of results, different sort of literature. That'll just end up confusing you and the audience. So be very sure you read and understand the abstract very clearly, that you are able to relate that yes, this problem is there and why is it important. Second thing is what the paper has done. What are they? What is the novel propositions that the paper have, come up with in order to solve the problem. So these two things are going to be there in the abstract. Then you move into the introduction. Introduction is actually a rather slow version of the abstract. It is going to explain the stuff that is in the abstract in more detail. Then it also is going to have a background section. So especially when presenting, and even when, when you're reading, then it's a different case. But especially when presenting, I would say do not pay a lot of attention to the background literature, because there's endless literature, right? People have been researching for hundreds of years, and it's just going to be endless. You are not going to be able to make head and tail of everything. That one paragraph of background literature is going to probably cite 20 other papers, and it is just not logistically, sensible to go on and read 20 other papers just to, cover that one paragraph. Just know that what the gist of that paragraph is, what other people have done, how is this paper different from what other people have done. So this is a very important thing again, which is going to be there in the introduction and the background literature. every author is going to discuss the literature, and then they're going to come on how is their paper different from the literature. This is where you have to be very clear. This is something that you need to understand very thoroughly, that why is this paper like what is this paper contributing. Basically that is what you have to put, that is the point that you need to put across, that this paper is contributing this. So make sure about that, and don't go reading about every little line that is in the background section. Other than that, introduction is going to have a very slow description of the problem statement as well. Another very good tip in order to understand as well as explain a problem statement is always come up with examples. Wherever possible, try to come up with different sort of examples that you can to motivate the problem statement. Now, this is going to do two things. One is that it is going to, so if you're able to come up with an example, that means that you have understood the paper or you have understood the problem statement well enough. So that is sort of a litmus test, sort of a check that have you actually understood the problem statement well enough in the first place or not. And the second thing is, if you can come up with different examples, you'll be able to visualize the problem statement better. Right. Then as you come up with different examples, you can relate more to the problem statement, and this will help you drive the point across to your audience. If you just speak a bunch of words, or if you just show them a slide which has like 10 points, people might not understand it. People might not, get their significance, that how is it going to affect anything in application or anything in real life. For this, examples here are very important. Thirdly, never copy an example from the paper. A lot of papers, just because of this thing, because they want to, they also want to motivate their problem statement, they put in their examples. Never copy the exact example from the paper. Again, because that just fails the entire purpose. That then you're just like that, you do not know that if you cannot come up with your own examples, you just do not know whether you have understood the problem statement well enough or not. Yes, use that example, you use it to understand what it is, and then come up with your own examples. Always remember, this is like a key rule here. Whenever you're presenting, and whenever you're presenting in a more formal setting, never take anything exactly from the paper. If a paper has given an algorithm, don't just copy and paste it. Write it in your own terms. If the paper has given you an example, don't just take the exact example. Right, make some other example, make something close by, that is fine. But you need to come up with your own stuff, especially when you're presenting in a formal setting. This is going to make a very bad impression if you just pick stuff up from someone else's paper and then you just put it. Moving on, so then you'll have the meaty sections, right? Then you'll have the sections where the results have been discussed. Now, this is a very interesting thing, and this is actually the place where a presenter's role actually comes in, because there are a lot of rules when you actually have to go and present a paper. Sorry, when you're actually submitting a paper or when the paper gets published. So, for example, the paper that we have, as you can see, it is only 6 pages. Why is that? Because the conference that we published in had this rule that you have to publish, you have to write the paper, and it cannot exceed 6 pages. So there are a lot of rules like that. So papers have been written, while taking all of that into consideration. And you do not have to take that into consideration. What you have to take into consideration is how you can drive your point across better to your audience. So this is where the way a paper is written and the way you present diverges. So the way a paper sort of goes about theorems and their results. So what a paper is going to do is they're going to give you results in a manner which are concise, but they're concise, they're correct, but at the same time a paper will probably not care for it to be intuitive. If I have to give an example, think about a very difficult math problem. One way to solve it is a teacher comes on the board and solves it, and another way is you just look at the guidebook and you go from one equation to another equation to the third equation to the fourth, and like that all the way to the end. Now when you go by equation to equation, what happens is you can understand, right? Looking at every equation, you understand that, okay, this equation is correct. The last one was correct. How are we getting this one from the last one? And how is this one correct? And blah, blah, blah. You get that it is correct. But at the same time, but you do not understand really nicely that how do you actually come to that? Like how, if I did not have those equations in front of me, how can I start from nothing on a blank paper and come to those equations? So how does that happen? Now that is actually in our schools or something, that is the job of a good teacher. They present it in an intuitive manner. So this is the same thing that you have to do in a paper. The paper is going to give you the results. All the results are going to make sense. Obviously, there is correct. The entire story is in the paper and it has been reviewed and published. So the results are correct. But how do those results come? How is someone going to start thinking about those results? What is the intuition behind behind coming to those results? Why did the authors bother to write this result there? Like if there is a theorem one written, theorem one says this, your task as a presenter is not just to say that how this theorem is correct. That is already there in the paper. Your task is to tell the audience that what intuition can the author have gotten that they thought that this theorem is going to help. Firstly, why is that theorem there? And a good way to decide it is try to remove that theorem from the paper. If you don't understand why a result is important, try and remove that result from the paper. Just imagine that the result does not exist. Now see where does the solution fail. So you have an entire solution. Your paper has a problem statement and it has an entire solution. And that solution is made of a bunch of results. Imagine if one result is plugged out, how does it affect the solution? Where is that you stop? Where is that you cannot move forward without that result? While presenting, that is how you have to present. Rather than coming with the result first, you need to tell them, see, this is our solution. This is what we were trying to do. And this is where we get stuck. Now, how do we get over this? How are we going to cross this obstacle? That is when you're going to pull that result. That is, suppose we had this result or we had this theorem or we had this something that we already know from this whatever place that the paper shows. This is how we are going to cross this obstacle. Then you move on with your solution to the next obstacle. Never put result after result. Never go that this paper discusses result one and then it discusses result two and then it discusses result three. That is if you do that, it's like you're just an audio you're just an audio book for the paper, and that is not the point. The point is to actually understand what they are doing. For that, you need to understand what is the significance, not just what the result is or how is it correct or how do they come to it. What is the significance of the result? That you can only understand when you evaluate that result with respect to the entire solution. So always have the bigger picture. Always go back to I'll say always go back to the abstract. So whenever I have to sort of read or present a paper, I always keep getting back to the abstract. Write it down, write very clearly down what your problem statement is. You're solving a problem here, and you want to tell the audience how are you going to solve this problem or how has this paper solved that problem. Go by a solution. Start with an intuition. This is how we begin moving towards the solution. This is where we would have gotten stuck. This is the result that we are using. This is the result that the paper discusses. This is how we climb that obstacle. This is how we move forward. And this is how we get to the next results. In that way, you have to piece all the results together in your solution. Now, the results that are going to be there in the paper, they might not be in a chronological order. So when you are going from a solution, it is very possible that this result on the fifth page actually comes here and this result on the first page actually goes there. The reason for that is because when papers are written, a lot of things are kept in mind, and it's basically that the more important results or more meaty results need to go somewhere forward. So a lot of things are taken into consideration, how the reviewer is going to perceive it, how or there are actually n number of things rather than just driving their point across. So it is not so don't always feel that if there is theorem one is definitely going to come before theorem two and then like that. It is very possible that theorem three is where you are getting your intuition. This is how you need to start. Midway of theorem three, you are using theorem one. So when you're presenting, that should be the order. It should always be guided by your intuition rather than how it is given in the paper. Now, when you move forward, can I stop sharing? Just- Right. So, okay, I'll just go back to see what points have I discussed. Right. So, so these are the basic ways in which presenting actually differs from both. It's reading the paper and writing the paper. When writing the paper, you are clear with the terminologies. You're clear with the problem statement. You're probably working with the problem statement for the last 6 months. You don't need to motivate it. You don't need to understand that the problem statement is important. You worked for it so long, you already know it. Everyone in your lab knows it. But the people who you're going to present in 30 minutes, they do not know it. So it is very important before you start that you make very clear why the problem statement is correct, and you bring the solution in an intuitive fashion. So these were basically the two things. Again, now your as a job as a presenter does not actually stop there. A very important third criteria for how good of a presentation is that you give is to realize that what was wrong in the research paper. Now, obviously every research paper is written by a human, right? It doesn't have to be right. Sometimes it is completely wrong. That is a very rare scenario, but it can be completely wrong. Most of the times it is a little wrong, and oftentimes what happens is the author is very cleverly going to hide or just omit a few details, like maybe they're not taking, maybe they're just not talking about a few considerations that they otherwise would have taken. Maybe they're not talking, maybe they just omitted a particular scenario because they know that their solution fails in that scenario or it doesn't perform optimally. So when you're going to present a research paper, your job doesn't end with telling how the paper is solving the problem. Your job also it also consists of critically analyzing where does it fail. So for that, I mean, it is actually so. If you're just going to present a paper in a very new domain, it would probably be hard. You would need some sort of a domain knowledge. You'd need some sort of a background. If this is, say, the first paper that you're reading in the domain, then you obviously cannot read a paper and understand what they have done wrong. But if you do have some background, if you do have some knowledge, always look at what are the authors missing. So the authors, so when a paper is written, in every theorem, in everything, what they're going to write that this theorem holds given these conditions, or this problem statement is a problem given these conditions. And in the entire paper, that is all they're going to talk about. So what you have to do, you have to go you have to diverge from the paper. Now you will have to go elsewhere, and you'll have to go and check what happens when okay, you do not really see. This is not. I think this is so the question that Aishwarya asked. I hope I pronounced it right. So I think this is with respect to the presentation that you're going to have right now. That is okay. I think that is just a like I mean that is not a very formal presentation that you're giving to sort of get into a PhD or get into a graduate school or something like that. So there, yeah, obviously you won't be judged on those basis, but this is just something that you need to keep in mind, while presenting a paper. Or not every time you need to have a background. So when a paper describes a problem, they're going to describe certain conditions. This is our problem, these are the conditions. Now as a presenter, what you need to do is you need to go online, search, does that problem actually occur? When does that problem occur? When does that problem not occur? A lot of times it can happen that a research paper is solving a problem that occurs 0.01% of the time in their scenario. And actually 0.01% is actually a big part. At that point the research paper actually gets published. Sometimes they actually they solve a problem that can theoretically exist but practically may not exist. Now, not saying anything against the research paper, but as a presenter, your job is to know that, and your job is to convey it to the audience, because the audience are going to have these doubts, right? It is going to be it is not a good practice, but it is going to be really embarrassing if someone in the audience asks you that you talked about this problem, when does this problem actually happen? Or in this scenario I just feel like that this problem won't really happen. So in that case, if you just if you do not have any answer, that can get a little embarrassing. And as a good presenter, your job would be to put it upfront that this problem actually occurs these many this many times. this is when the problem would occur. These are the cases, these are the scenarios when it occurs. So that is something that you need to go outside of the paper to check. Again, in the solutions, the paper is going to assume a number of things. They're going to assume that there are certain conditions that hold, and they're going to talk about this kind of stuff. Always go on and check, when do these conditions hold? What is the real life scenario where these conditions hold? What is the real life scenarios where this condition does not hold? What would be this paper's impact there? Maybe your answer isn't right. Maybe that is something that you were just thinking. That is fine. But it wouldn't be fine if you just do not put in any effort, of going around and checking it. You have to move outside of the paper as well. So now coming on to how can you actually, a few other sort of tips that you really need to sort of keep in mind when, going for a presentation. Now, so the audience can ask anything. Okay, that is the really maybe the fun part or the scary part that you can say for a paper presentation. You're put in the spot. You're describing something. An audience can ask anything. Make sure that you actually clearly understand every line of the research paper, and I literally mean every line. If there is one sentence that you do not understand, you need to go back, you need to check, you need to make notes about it. This is going to do two things. One is this is going to this is going to help you understand the paper better. Second thing is you'll also realize, right, that this is the sentence where a first time reader or someone who has come across this for the first time gets stuck. So that way you can also explain it better to your audience. That way you can also put more emphasis on it. So you're actually this is one really nice thing as a presenter. When you're reading the paper for the first time, you start as a you start as a layman as well. So you, while you're reading, while you're actually preparing your presentation, you also, if you've prepared it well, you get a good idea of how a layman goes from zero to understanding this paper. Make sure you use that knowledge. Do not use what the way they have given it in the paper, the sections they have divided in the paper. Don't make a slide on abstract and a three on introduction and like that. Use your knowledge. You started from zero. You started as a layman. You went to understanding the paper. How did you cover this distance? You need to get the audience to cover this distance in 30 minutes. So the audience is there, they are starting as a layman. How are they going to cover this distance? So the best way to actually is to look at your journey. What was the stuff where you got stuck at? What was the thing where you needed to, think about maybe 1 hour, 2 hours, just lie down, close your eyes and think about and visualize to understand. If there is that, sorry, okay, I'll just take this question. We're supposed to present as if it's our own paper. So would it be still right not picking out what's wrong? Yeah, yes, I think that would still be right. See, there are a couple of reasons for that. One thing is that even if you're right, even if you're an author, thing is it is actually a good practice to pick out what's wrong. Uh, Digressing a little bit from the topic, I'm just so whenever you go on writing a paper, a very good practice is to actually pin down your own problems in the paper and actually mention it. The reason for that is twofold. One is that you're being very transparent and you're not trying to fool anyone. The second reason for that is that if a reviewer picks out your problem, then it's going to be an issue. If a reviewer picks out something from something that, say, your algorithm does not solve, or anything that your result does not hold, then it is going to be a spot on your paper. Then it is going to make it difficult. But if you put it forward yourself, then it actually comes out as you being transparent. So it's a mixed thing, both practical and ethical. And finally, I would say that it is actually a good thing to uh, pick out what is wrong. Uh, you are presenting it as your own paper. That is correct, but keep in mind your point is not to say that this paper is the greatest thing ever. Your point is to tell the your okay. Again, digressing just a bit, what actually is a paper, right? So when you're studying, say, when you're studying a subject, when you're studying a course, you write notes, you're making notes. Why do you make notes? You make notes so that you don't have to go back and look at everything all over again. So what you do, you make quick notes that this is it, this is it, this is it, and next time when someone has you have to study, you just go through those notes. And suppose your friend has to study and they do not have as much of time, what do? You tell them, you take my notes and you study this. This will help you get stuff faster. This is exactly the point of publications. Point of publication is not to get citations or awards or things like that. Point of publication is that there is a scientific community. That community is of thousands, and lot there are hundreds and thousands of scientists all over the world. Now, you do not want other people to do stuff that has already been done. You don't want people to waste their time, money, and energy on stuff that has already been done, and you don't want to do that. So, if you get a result, if you do some work, you publish it. So, the point of paper is not to, even if it's your own paper, the point is not to show that it's the greatest thing that has ever, been bestowed upon mankind. The point is to sort of drive how can it help other people, how can it help the scientific domain. And for that you need to make a few things very clear. Again, I'm going to come back to this: what the problem statement is, how you solve the problem, and this is a very important point: how when does this thing does do when does it not work, where does it fail, where is the scope where you can maybe work more, or this thing can be improved, or someone else can probably work. That is also a very important thing. So when you're going for a presentation, make sure that you say that. Make sure that you spend at least 1/4 of your time of the presentation discussing that, because that is where it actually sort of in a more practical scenario, that is where the others are going to understand. Or suppose you're in a more formal setting where you're being judged for the presentation, that is where other people are going to understand that you've actually understood the paper, and you're not just or not you've just not thoroughly memorized it, because everything's there in the paper. Everything else you have talked about is more or less there. You just understand, you just come up with it. Now here is where you need to digress outside. You need to understand the problem in order to get the flaws out. If you're not able to do that, you see, obviously this is going to happen. You won't be able to do that in your first presentation. You do not know the domain well enough, and a lot of authors are going to mask their major faults as well. So it is not something that is just easy or just very straightforward, but make sure that you look at a paper with that sort of a mind. Every line you read, ask why are we doing this? What if this line did not exist? How is this going to impact the solution? What if this para, what if this section was not there? What if the author puts a bunch of results, a bunch of equations? What if we did not have this equation? Your job is not to just say that this equation is right, LHS is actually equal to RHS. Anyone can do that. The authors have already done that, the reviewers have checked that. So that is not your job. Your job is to say that why do we need this? You put this equation out, this is where we're getting stuck. You plug that equation back in there and see how we got, how we get unstuck, how we are able to move over that obstacle. So that is basically what presentation is going to be all about. Other than that, just to sort of give you a heads up, suppose you have 100% of the time, I would say put 20 to 25% of the time just on the problem statement. Because the thing is, if the problem statement remains unclear, your everything else you are going to say is going to be pointless. So your problem statement, so you put 20 to 25%, go really slow, explain 5 examples if necessary. You also look at your own experience. How long did it take you to understand the problem statement? What was that example, or what was that thought that just clicked that, okay, this is why the problem is important. How did you get that, that just moment of realization? Try to put that in front of your audience as often as possible. Put considerable amount of time so your audience know that yes, this is the problem and it is very important. Now you move over to the solution. Spend about 50 to 60% of the time. I would say 50%. If you're spending 25% on the problem statement, spend 50% on the results. Don't go into a lot of technicality. Suppose you have a bunch of equations, do not bother. If there is a bunch of equations that that took you 4 hours to sort of understand, or 3 hours to understand, or to write down every little thing one by one or something like that, don't try to sort of put it in your presentation. The audience is not going to understand it in 30 minutes, and they'll probably zone out after that. So don't put that. Keep it as intuitive as possible. You have a bunch of equations. Just put the ones which actually have physical significance. Don't put the ones where you're just doing, say, a bunch of math, where you're just doing algebra, where you're just doing some sort of a trick. Here we take a log and blah blah blah. That's not important. You just put the ones which have physical significance, that this equation tells us this is how you can physically understand it. If you cannot understand a physical situation, if it's just algebraic, some algebraic trick, again, it's beautiful, but it's probably not for a presentation. So you go in that manner, go intuitively, put all those results there, never copy something from the paper. And once you have ended, always talk about the things that these equations could have missed. Even if it's your thoughts, that is fine. See, we're all learning here. And even if you're in a formal setting, and you just have a thought, you're not sure. The paper could have you're just not sure that the author's results are going to apply in this situation. You've just come up with a situation and you just feel that it might not. Just put it out there, just explain it, just put a question mark. You don't have to make a statement that you think that it won't happen. Just put a question mark that I think that this is a situation where the paper might fail because of this, because of my rationale, which is this. Just put it out there. Do not hold it back. And if you're not very sure, obviously do not make a strong statement, but don't hold it back. Put it out there, because this way the audience is actually, especially if see, the one thing is the audience are also going to get a new way to think. This is going to help them understand the paper. And if you're being formally judged, the other people are going to understand that you took in the effort, you put in the time to understand that. So that is a third very important thing. And I would say that that is very and especially if you're being, again, I'm coming back to it, but especially if you're being formally judged, because your your credibility as a researcher comes there. Because what is research? You basically need to understand what is being done, and you need to find out what has not been done, so that you can do it, right? What are you going to do it? If you just read a research paper and you just understand a problem and get to a solution, what are you going to do it? So trying to understand what has not been done in the paper is very, very important. And that is actually where your credibility as a researcher comes in. Your researcher's instinct, or if I may say, that is where that comes in. That these guys missed this, maybe we can try this. Maybe why did they miss this is because maybe come up with your own examples. Think of something, think of some rationale that they're making this assumption which might not hold, and that's why I think they have missed this case. This is going to be especially when you're being formally judged, it's going to be really, really important for the presentation. And it's actually going to put you across as a good researcher. It's actually all obviously also good practice, because you're going to if you're pursuing research, you'll be having to do this a lot. So in that way as well. So this is how I would say, you should structure your research presentation.
Your paper presentation which you showed us, it was of 6 pages. So
Great.
how many slides would you expect from us to present to our presenter? In how
Okay. So there are
much
a lot.
present to our
So it's actually a very personal thing, because the kind of information you put in the slide, the amount of time that you spend on a slide is actually, it can be really, it can depend a lot from person to person. How I try to do it is, if I have, say, a 30-minute presentation, I would probably go for 45 slides. I usually do 1.5 the number of slides, and every slide should have uh, at least some amount of different, obviously, you just don't have to make it 45 slides. It's not like, just because I had to make it 45, I write thank in one slide and you in the other slide. Not like that. Obviously, it has to convey some sort of meaningful information. So if there is, so it's not about the number of pages, right? A 6-page paper, again, see, a 6-page paper can have theorems which are just very intuitive. The theorem, you tell them, and you feel, you just read the theorem once, and you are able to visualize, okay, this is why it adds up. Or it can have a theorem which is very hard to understand. Now, if a theorem is very hard to understand, you'll need to break it down. You'll need to break it down in what the problem is. You'll probably need to break it down on every different line of the theorem, that this is what this line says. For example, then maybe you'll need another slide to give an example that this line of theorem means this. You move from this example to this is an example of what this line of theorem says, and then you go to another. So you cannot actually look at a paper and tell. It actually depends upon how complex that is. And I think the best judge for that would be you when you are understanding the paper. So when you read a theorem and you just understand it, you can actually go on and assume that your audience will also understand it that way. But if you read a theorem and it's just like you've read it 5 times by now and you still don't understand it, and you really have to dig in, maybe that theorem is something where you need 2 or 3 slides or 2 or 3 examples to explain. Also, yeah, coming to this, always put a lot of examples in there, because uh, because when you are reading the paper, you're very diligently sitting there to study. A lot of people in the audience are not sitting there just to study. They're scrolling through their phones. They're just sitting there. They're eating, drinking, whatever. And not everyone's just that into to study probably, and that is how you need to take it. So if you give them a lot of complicated stuff, they'll probably zone out. You'll probably lose your audience. So always give a lot of examples, something that they can see. This is what I'm saying. You can see it like this. This is how you can associate it to their visual memory. So that would be a thing that you should actually take care in a presentation, because that is one way you'll actually hold your audience, I would say.
Anyone else? In the meantime, Amogh, I will prefer you just if you summarize in 5 minutes that whether in an undergraduate student starting research at the undergraduate level is good enough or not. Matlab, how do you think like this regarding the doing research at undergraduate level? Is
Okay.
it matlab, one can do it or not, or how to continue within just 5 minutes of something?
Okay, so I will go on my personal experience. That's all I can say with. I will go over my experience and the people that I have seen. Um, I'll be honest. This question is actually slightly funny to me, because I would say that if someone has to do research, they have to do research or have research exposure in undergrad. There just is no other way. I honestly know of very few people. See, there can be some corner cases that you're doing something in the industry or something from where you move into research, but trust me, that's 0.0001%. If you want to go into research, I mean that that is undergrad is actually the place, right? Because all your graduate, what happens is the graduate school applications, the graduate applications, all of them are going to depend on your research presentation skills, research. Sometimes even publications, sometimes your research experience, not necessarily publication, but your experience. Have you worked in a lab? Because it actually differs a lot. Just learning something to thinking about it in terms of research. Uh, I am not sure how to put it into words, but maybe you will get it from experience. But it actually differs. One way I can sort of intuitively to tell you this is how it actually is different, reading something from the book and reading something from the research paper. So they're both text, right? They're both, just written stuff. But reading one thing from the other is very different, right? So when you have to, if you feel you have to go to research, you need to know the other. You need to know how to read research papers. You need to know how to present them. You need to look at the stuff that you've learned and everything else in that research mindset. And when is that going to come if not undergrad? Because graduate and PhD is where you sort of go into research. Like by masters, people usually have their thesis, or they're doing their thesis in some research domain. So by that time, it is sort of expected that they have at least some research experience. Again, there can be cases that you do not have and you're starting fresh. That's fine. But in an ideal case, I think you need to have research experience, right? Because And being more pragmatic about it, I would say that, if you're going to an institute, if you're a professor, you're going to get 200 applications. 200 is a very low number. You're probably going to get 2000 applications. Why will you take someone who does not have research experience over someone who does? You're thinking about about it from the professor's perspective. They don't have any, they don't know. You might be a very good, very, very enthusiastic student, but they don't know you. For them, all of you are equal. Every 2000 application is equal. So they need someone who they can trust with, that they'll contribute to their research. How will they put that trust in you? Only if you have that sort of experience. So I think, yeah, undergrad is actually undergrad is like, you have to, I would say, rather than you can. This is where you have to do it. And every lab that I have worked with, I think, there have always been undergrad research students. I started researching when I was in my second or third year. I was working in labs, and that is when you look at people and you learn and you actually get to explore a lot of research domains. You can, that is also a time where you can afford to, do research maybe in 5 different subjects. So I've been researching in neuroscience, in psychology, in software verification, in distributed computing. I probably cannot do that 5 to 10 years from today, but this is a time where it's just easier to, just a minute. Yeah. Sorry. This is a time when it's easier. You are learning a lot of stuff. So this is a time when you can nicely connect that this is what we learned. This is how it connects to research. Okay, this is how what we learned. This is how it is applied. This is what they're not talking about. This is what they're using. All of that stuff. So I think, yeah, undergrad is definitely a place where you have to start. And I would say, if I mean, in an ideal scenario, it's second year is probably the best time to start, if not first year.
Thank you. Thank you, Amogh.
And how much time should we invest on our paper reading?
Um, so okay, I personally did not say it, think of it that way. It was more like, for me, it has been whatever I find fascinating. I used to go on and read papers about that. So I did not have a set amount of time. But having said that, I think I did, uh, whatever I found fascinating, I would just go on and read papers. Even if you could not read papers, I am probably, if I can write in the chat. Yeah, I can write in the chat. So there are a few, so I know stuff about computer science, but I think you can look at it. I think there would be such stuff in other fields as well. So there are a lot of blogs which discuss research papers. So towards data science or Medium, these are places. So a lot of blogs there are like, they'll just take a research paper and they'll just discuss it. They'll just discuss it in a very intuitive manner. So all of us kids, what do we do? You open your Google, right? You get a bunch of blogs there. You get a bunch of articles. You click on one and you start scrolling it. You start reading it. So if you visit these sites that often, or if you visit these sites very often, this is what is going to come in your recommendations. So in your recommendation, it's going to be like, this new research paper came out, and this is a blog post discussing about it. This is a blog post which describes it. This is a blog post which describes what this research paper is doing wrong, or anything like that. So I actually spent a considerable amount of time just reading that, just when I'm eating or something, not too formally, not always in my study time, or not with a pen and a paper, just like that. Okay, this thing looks fascinating. Let me just have a look, just like that. So I would say, yeah, I did spend a lot of time into reading papers like that and reading research material like that. Another good place is Twitter. A lot of professors are active there. A lot of professors will keep on putting their new research advancements. They'll keep on announcing that. So I've had a habit of that also. You just keep scrolling through Twitter. You follow a bunch of professors who you like. So it can start anyway. Just Google a field that you like. Go into professors, or Google a field that you like and enter a college's name that you like. See which professor is working on that. Follow them on Twitter. They're going to put an update that they put an update that our lab just worked on this and this paper got published. They'll just put a link to their paper there. Most of the paper these days are free. Most of them are there on archive. So that way you can just go and study. Any preferable website for finding out research paper? archive is one thing, and then you'll have bio archive and stuff like this. So these are, I think most of the paper today are available freely here. Other than that, I think if you just if you just go on ResearchGate, lot of professors just put their papers there. So suppose you have a paper titled XYZ, a good thing would be to go XYZ ResearchGate or PDF. Just put this string in Google, and you'll probably end up finding the PDF from somewhere. I personally did not feel that it was ever hard finding a paper. Most papers are freely available today. So, and I would say that these papers are okay, but do look at these blog posts. Do look at these blogs and articles. It's just more easy. You'll probably not think of eating or having a milkshake and then reading a PDF in IEEE format. That is not. I don't know. That's something with me. That's maybe a personal thing, but that's not a very lucrative idea in my head, that I'm having breakfast and I'm reading an IEEE format paper. It is much easier if I'm reading a blog or an article, or the paper presented in a more colorful manner, if I may. So do look at those places as well, and they also give you a commentary on the paper. So that's also very important. That doesn't only tell you about the paper, that tells you about how another person looks at a paper and how another person should look at a paper. They point out the mistakes in the paper that they feel, they point out the good stuff. So they're also giving you a third person's perspective on that paper. So do look at those blog posts. I would say they're really helpful, and if you get into a habit of reading those, I think you'll end up reading a lot. You'll end up knowing a lot. Other than that, I think the research world is just way too fast paced these days. So the paper that I just showed you, so that publication came last year. So the work I did in last year, that field came up in 2017. It is that recent, and I had 200 plus papers. So in 3 years, there were 200 plus papers. We had 200 plus papers to do our literature survey from. So the research field is just very fast paced these days. If you just rely on books, it's just not possible. A book probably takes 5 or 10 years to just be written. So if someone starts writing a book today and they end in 2026, everything that happened between 2021 to 2026 is probably not there. And as a researcher, that is probably the meaty stuff for you, because everything that has happened before has already probably been taken up. Like, your best bet is to go and look at stuff that is recently happening. Obviously you can be one of those exceptional people who takes up a problem from 1960s and solve it, in which case you'll probably in which case you should probably not be listening to someone like me speaking. But yeah, in most other cases, I would say you should target stuff. You should be familiar with stuff that is happening recently. So books logistically just cannot suffice for that. You need to get into a habit of studying research papers.
Anyone else? Anyone else wants to ask anything? No one? Then we can.
Okay, then. Yeah.
So while reading this paper, we will get stuck at several points for which we will search on Google. So while making our presentation, we have to mention all those things in presentation, or is it okay without it?
Mention as in that you went on, like.
No, sir. Sir means whatever we search on Google. So what are those those answers of our doubt? So we have to mention those answers also.
Yes, so exactly. So that is a very important thing, right? Because the fact that you got stuck at some point means that that point was confusing, right? See, it can happen that you got stuck on a point which is very straightforward and it just didn't click you. That happens with everyone. And if you just go on Google and you find a solution which is just very simple, it just didn't click you, maybe you can just leave that. But if you are getting stuck at a point, what does that mean? That means that that point is confusing. That means that it needs extra effort to be driven to the audience. So wherever you get stuck, make sure how you got unstuck, how you got the answer to that solution, and make sure you put that answer in your presentation so that your audience does not get stuck. Or you can also, in a way, make sure that when you say that, you can ask the audience, you can tell them that, you know what, and one place where you might get stuck is this, and you can tell them where you got stuck, and then you can give them the solution, and this is how you found the answer, and that this is the point, and it is possible that you might feel this or you might get stuck here, but this is the answer to this. So I think that is a very good practice. So wherever you are getting stuck, there's a very good chance that the audience will as well, because you are reading the paper line by line diligently in your home. They're just listening to you speak. So there's a good chance that the audience will get stuck there. So it's a very good idea to explain the answer in detail about that.
Okay, sir.
Anyone else? No one? If anyone wants to, you can raise your hand as well. Anyone else wants to ask? No? Then we should thank Amogh for giving his valuable 1 hour time to us. And thank you very much, Amogh, for giving so much, this much of details regarding how to present and whether it is good enough for the undergrads to start the research or not. Thank you.